All right, what is up, everyone? So, we started off the live stream with a technical difficulty, but I think I've got it resolved right now. It looks like it. So, welcome. Thank you guys for joining me. I really appreciate your time. I'm Will Button, and this is DevOps for the rest of us. So, you might have figured out this is my first live stream, and we're probably going to encounter some technical difficulties. But when we do, just bear with me and I will get through them as fast as we can. So I really wanted to do this DevOps for the absolute beginner and kind of just break things down and share how to do DevOps with as many people as possible. And there were a couple of reasons for doing that. First of all, I don't think I'm going to shock anyone when I say that the global economy is just complete shit right now, and it's going to get a lot worse. So some of you who are watching might be currently without a job, or maybe you've got a job, but you don't have really a high level of confidence in how long that job is going to last. Or maybe you've got a job, but you've heard some things about DevOps and you just want to learn something that you can apply to your current job to make that whole process a better experience for you and your team. So I can help with all of those things. The other part of the motivation for doing this is every week I get emails from recruiters looking to fill DevOps roles. And I've called up quite a few of them to ask them, I was just curious, hey, are you all sending me the same position? You guys are fighting to fill it, or do you have all these positions open? And the overwhelming response from all of them was that they just can't fill these DevOps roles. The people with the right skill set don't exist, or that they do exist, but they already have jobs and aren't willing or wanting to switch. And so I can help bridge those two communities together. And I've wanted to do this for a really long time. But thanks to COVID-19, it just seemed like this was the time to do it. So here we go. I'll tell you a little bit about my background for anyone who doesn't know me. Actually, a lot of you don't know me, so I'll tell you a little bit about me. I've been actually working in IT and software engineering since 1995. So that makes me a really old fart, and I'm kind of okay with that because not everyone gets that opportunity. But I've been specifically working in DevOps for about 10 years now. And I was sort of doing it before I even knew that such a thing existed because I've worked in both software engineering and in IT. And the way it kind of came about was, whenever I was in software engineering, I would create code and I would, send it off to be deployed, and something would go wrong, and it was frustrating. I couldn't figure out why. Or whenever I was in IT, I would get code that had to be deployed, and I would go to deploy it and look at the code and just think, geez, who wrote this? But over time, from working both sides of those, the people on both sides became my friends, and one day I had this realization, wait a minute, I know the people on those other teams. They're my friends. They've been over to my house, they've drank my beer, they've played my video games. I know they know what they're doing, so there's got to be something else wrong here. And so I started working both sides of the teams, and that's whenever I realized that the biggest barrier there is communication. And I'll give you an example of that. Let's say you build a new application and you target it to run in a Docker container, and it goes off to deployment, and your IT ops team gets it, but they don't have anything set up for a Docker infrastructure. Well, that's a project that's going to fail, right? And that's where DevOps really starts to show its power, is because it brings those two teams together into a single team so that those conversations happen earlier. So you will be you'll be planning your project, and if you decide you want to go with Docker, the IT ops team will be right there. And so they can either tell you that they don't have any capabilities to support Docker and you choose a different technology, something that they have support for, or they know that the project is coming and they start building out the Docker infrastructure to support that project when you're ready to go. So that's kind of my background. I've also done well over 100 videos for pluralsight.com, egghead.io, and caster.io. And so I have a background in both explaining technical concepts, but I also have a real job where I do this stuff for a living. So let's jump right into it. And we're starting with the absolute beginner, so let's start with what is DevOps. And I think the best way to start to explain to someone what DevOps is to take you back to a time before DevOps existed and talk you through what a deployment process would look like then. So prior to DevOps, you would write your code, and then as your code was, once your code was ready, you would take it, package it, build it, whatever the appropriate thing to do for that code base was, and you would send it off to a release team or your IT team or IT ops, however that company was built, and they would take that, and then most of the time they would SSH into a server, copy the files over, install and configure anything that was necessary, stop the services, restart the services, move on to the next server, and repeat that until it was done, which, if you're only running 5 or 10 servers, that's kind of a pain, but it's doable. When you get up to running your application on thousands of servers, though, that breaks down really, really quickly, especially when you think about it from the perspective that if there's a problem with your deployment and you have to roll it back, the rollback process, again, is manual, SSHing into those servers, undoing any config changes you made, restoring the previous version of the code, restarting those services. And so it was this huge manual deployment. And so what DevOps is really trying to do is automate that whole process by bringing those two teams together in the form of communication and software automation to make that process easier. So in a DevOps world, what that's going to look like is you'll commit your code to GitHub, which is going to kick off a build job from a build server or a CI/CD server, and then that's going to run your tests on it. So that's another benefit you get there is you can run your tests on your code base, also check for security vulnerabilities before you actually deploy that to production. And if your tests or your security vulnerabilities fail, you can stop the deployment process right there before you've done anything to impact production or impact your customers. If by chance you do have to roll it back, again, we've automated everything, so the rollback process itself is automated too. Now, it's still going to be painful because you may have a server outage associated with it, but since everything is automated, the recovery time there is going to be much, much faster than what it was in a pre-DevOps world whenever you have to do everything manually. One of the biggest things that I could advise you on, though, whenever you're going down DevOps, I see a lot of organizations trying to build a DevOps team. And the core problem with life pre-DevOps was you had software engineering and you had IT operations, and they just threw stuff back and forth over the wall to each other. And so if you create this DevOps team, you're really setting it up where you may actually just be introducing another wall to throw stuff over. So now instead of having one wall to throw things over, there's two walls to throw things over. So it's important if you do have a DevOps team that they are integrated with the engineering team and the IT team as well. All right, make sense? I hope so. So I've got the chat stream going up over here, and I really want this to be beneficial for you. So if you have any questions, if I introduce a concept or a term that you're not familiar with, pop a question into the chat and I'll take care of that. Odds are I'm going to forget about the chat at some point, but I will come back to it at the end and then try to address them there. And then I will also follow up with everyone after the live stream is over. And I've got some ways for you to get a hold of me if you hang out till the end of the live stream. So we talked about what DevOps is, how it can automate things, how it makes things smoother and faster. Really, one of the biggest benefits from that is time, right? So if you're not manually deploying and releasing code, it gives you time because, let's face it, I mean, that's a really boring job. If you have to SSH into 15 servers and copy files around, nobody wants to do that. You would rather be working on something else. So by automating that, it frees you up so that you can go work on the features of your application that you're really excited to work about. It also gives you time so that you can do non-work stuff. And for some of us in engineering, non-work stuff is kind of a non-existent thing, but you can take that extra time and you can spend it with your friends and your family, or spend it on hobbies, or however you want to do it, so that you can sort of self-direct your own work-life balance, so that you stay healthier, healthier mentally, healthier physically, and healthier in your relationships, instead of just being consumed by work all the time. So that's kind of a lot of background information. Let's get to talking about how do you actually start. And that's actually one of the things I struggle with in a lot of the DevOps presentations and literature and websites that kind of introduce the topic. To me, they feel very academic, that there's this huge learning curve of you have to learn these principles and these, these theories and like all of this academic stuff before you actually start doing anything. But, if you think about any programming language you've learned, what's the first thing that you did? The very first thing you do with any programming language you learn is you create a hello world application, right? And then you start building on the success of creating that first little application, even though all it did was just, usually print a string out to the screen. And so that's kind of how we're going to approach DevOps. We're going to do quick little wins that do tangible things that we can recognize and acknowledge, and then build upon that. And then once we get those implemented and working, we can come back around and we can talk about the philosophies that are actually backing why we did it that way. So this is going to be the first of multiple live streams, and in each one we're going to be working our way through an application. I've got an application that I have to deploy, and so we're just going to be working through that live through these live streams, and talk about all the different things that we have to do to get that deployed. It's going to be end-to-end, so we're starting with creating a VPC in AWS. We're going to build out a Kubernetes cluster to run our application. We're going to have content CDN, or content delivery network, to host our static apps assets, be setting up some DNS names, just everything from beginning to end. And we're going to do it all using DevOps principles. So you get to see this start with a blank slate. You get to see how we do each step along the way, and then why we make the choices that we do. And then at the end, you'll have experienced a full project from beginning to end. So this particular project is a small project. And a lot of times with DevOps stuff, that impacts how you do things, because you're going to do things differently if you're only serving 1,000 users versus serving 100,000. And so when we hit those different areas, we'll stop and we'll talk about that as well, at how we might approach that from different scaling perspectives. So let's do this. Let's jump over to this screen here, and I'm going to explain to you what a typical AWS environment might look like. This actually might look like your AWS environment, and I'm going to talk a lot about AWS, mainly because that's where I spend a lot of my time working. But if this goes well and this provides value to everyone, then we'll actually extend this and we can circle back whenever we're done. I can't believe I said circle back. Damn, I'm going to lose points for that. So anyway, when we're done with AWS, we could come back and we could do the same thing with Google Cloud Platform, GCP, or we could do it on Azure or Azure, however you want to say that. I'm a redneck, so I tend to slur my words, so apologize in advance for that. So there's a lot of options available for us here, depending on what's valuable to you and what y'all want to see. So let's start here. We've got this blue screen here, and we're just going to pretend that this entire blue screen is the internet. All right, I'm going to move my mic here. So we've got, Google over here, and let's say we've got Facebook over here, and then we might have, some more websites over here. Who knows what kind of websites are out on the internet. And then I'm going to draw this big box right here. And inside this, we're going to call this box AWS, Amazon Web Services. All right, and this is not to scale. I'm not drawing AWS larger because it's larger than any other sites on the internet. I just need room to draw here. So let's take a look at what your application might look like in AWS today. So you might have an EC2 server here. EC2, if you're not familiar with it, in AWS is just a virtual server. It's like any other computer that you can log into and execute commands on. And so that's going to run your website, right? And then you're going to have a database here because you've got to store information from your website down into this database and then retrieve it from that database. And so those two are going to talk right there. But your customers are out on the internet. They're not in AWS, right? So this web server here is going to have a public IP address. And we'll just represent that with X's. And then also, probably more importantly in this scenario, is move this over here. I'm going to draw a little laptop here. Whenever you're ready to deploy your code, you're actually going to connect to that public IP address to send your code to that server, right? And restart the services. And you need a public IP address to do that. Same thing for your database. You're going to have to log into your database server and access it so that you can run database queries or update scripts or whatever needs to be done there. So it's going to need a public IP address as well for you to get into it. Now that's going to work. There's nothing technically that won't work about that. Where that gets into an issue though, and I keep sliding this over here because I'm left-handed, so I've got my arm like in this 360-degree circle. My shoulders are hunched over. I'm in the fetal position because that's how I write. So this AWS has a fixed list of public IP addresses, right? And the problem with that comes from the fact that every hacker or malicious person on the internet knows what they are. So we're going to draw a bad guy here, and we'll give him a little sack of Bitcoin that he's holding, and then he's got his middle finger in his air there, flipping you off because he knows what he's about to do. Because what he's going to do is he's just going to continuously poll every IP address that AWS has, looking for anything that answers. And after we've built this infrastructure right here, we've got an EC2 server and a database that are going to answer. Once someone with malicious intent sees that answer, they're just going to start pounding away on it. They're going to be trying random usernames and passwords, trying to break into it. If you've set decent username and passwords, that's going to take them a really long time. But the other thing that they're going to do is just flood your system with traffic, right? And there's actually a possible scenario where they can send so much traffic to either your EC2 instance or your database server here where it's not able to respond to your customer's traffic. And that's called denial of service or DOS attack. You may also see that written as DDoS attack, distributed denial of service. The difference between the two is for a denial of service, it's coming from one person. Distributed denial of service will be multiple computers targeting your IP address. So that's why we don't do it this way, all right? But I get why some people set it up, just it's easy, it's quick to do, and they just may not have the knowledge that there is a better way. The better way is what we're actually going to do during these live streams. So we're going to start by carving out our own little partition inside of AWS. And we're going to create what's called a VPC, or a virtual private cloud. Now this is an internal network that's only going to work inside of our little box that we made in AWS. All right, so we can put our EC2 instance in here, and we can put our database in here, and neither one of those have a public IP address, so there's no way for this guy to get into those. We need a way to get into them though, right? So we're actually going to build a VPN, right? And so we'll be building the VPN as part of these live streams. And what a VPN allows you to do, I'll draw another laptop over here. A VPN allows you to do an encrypted connection into your VPC. So you'll establish an encrypted connection with the VPN. Once that's established, you'll be able to talk to the devices that are here inside of your VPC as if they were on your own network, basically. So that solves that part of the problem. The other part of the problem is our customers need to get access to it, right? We're trying to use this to host our website. So we're going to deal with that through using what's called an elastic load balancer, or an ELB. So what an ELB does is it sits right here on the edge of our VPC, and it actually has a public IP address. It actually has multiple, and I'll come back to why it has multiple addresses in just a minute. So whenever our customers try to connect to our website, they're actually going to connect to this ELB. The ELB is going to look at the traffic and say, oh, he's trying to get to this website, route the traffic through to our EC2 instance, and kind of act as a broker or a proxy in between the two, so that our web server here is never publicly exposed to the internet. So I mentioned this has a public IP address, which means that our hacker buddy over here, he's going to find it and he's going to start hitting it just like he did our other infrastructure over here. The reason that we care less about it in this scenario is because, number one, we've only opened up the ports that we need exposed over here. So we have port 80 and port 443 to serve our web traffic. Over here we had those same ports, but we also had port 22 open so that we could SSH into that server. And if you're not familiar with what TCP ports are, that's okay. We're just going to talk about them at a high level, and then we'll go into them a little bit deeper in the next live stream as we start building out our network. So our attacker is going to find these ports open. He's going to start hitting them. And he's not going to be able to do anything except access our website. Now that doesn't mean he can't do things like SQL injection attacks or cross-site scripting attacks. You know, those are still options available to them. And so we'll have to deal with that with another technology called a web application firewall, or a WAF. And so we can take care of that as well. The other part that we have to deal with here is the denial of service attack. And this is why I mentioned that it has multiple IP addresses, because with a denial of service attack, you know, whenever it comes in and hits your EC2 instance, all you can do is just let it hit that instance. But with an elastic load balancer here, the more traffic that gets sent to this, for example, from a DDoS attack, this thing starts expanding in capacity to absorb all of that. And so it acts as sort of a layer of protection to protect you from DDoS attacks. All right, so that's kind of what our AWS architecture is going to look like. We're going to run within AWS. We're going to build a VPC. We'll access it through a VPN. We'll deploy our services inside of here, and we'll only expose the parts that we need to through elastic load balancers, so that we don't, so that we don't have unnecessary ports exposed that increase our attack surface area. So that brings us up to 25 minutes for this. And I want to keep these kind of short. You know, I know that your time is valuable, and I don't know about you, but whenever I look at a YouTube video, or any video really, and I see that it's an hour long, I almost instantly just scroll on past, because it's hard for me to commit to an hour. You know, maybe I have commitment issues. Maybe Yeah, maybe that's another live stream. Anyway, so I'm going to keep these short. Try to keep them at around half an hour or so. And yeah, I forgot where I was going with that. So anyway, the last part I want to do for each of the live streams though is do a 5-minute Q&A. So I've actually got, you can see here this stack of cards, and each card has a question that someone has asked me at some point in the recent past about either DevOps or software engineering or career development, all along those lines. So I want to end each live stream with just a 5-minute session where I run through as many of these cards as I can, or as many questions in the chat that exist. And so if you have questions, pop them into the chat. We'll get to them. If I don't get to them before the end of the live stream, we'll follow up with them next time. But let's get started with our 5 minutes here. So question number 1. Did Carol Baskins kill her husband? You're damn right she did. Next question. All right, this is a real question. How do I deal with vendor lock-in? And I get this question quite a bit, actually. So by vendor lock-in, a lot of people I talk to are worried about putting their entire infrastructure in AWS or in Azure or in Google Cloud Platform. They feel like if they go with that, then they're tied to that specific vendor. And they're right that they are tied to that vendor. But as far as vendors go, I mean, if you go with any of those three, those are pretty rock solid vendors. You know, if you were using a hosting service from, your neighbor's teenage kid down the street, sure, it's probably a good idea to have like a backup plan. With AWS, GCP, or Azure, I personally don't think it's a huge issue. And then let's look at the alternatives to dealing with that. So the approach that a lot of people want to take with dealing with that is they want to deploy their infrastructure to 2 or 3 of those services, right? So they want to run on both GCP and AWS. And you can certainly do that, but you're taking on a lot of technical overhead to do so. Like if you have something in AWS, it's not a one-to-one counterpart of the exact same thing over in GCP. So you're going to end up doing duplicate work to build out your infrastructure. And along with that duplicate work, there may be some like duplicate work because it's not a one-to-one thing. So, what you have to do to work with this service in AWS, you may have to do differently to work with in GCP. So you've got, different branches of your code or different types of infrastructure and things like that. So I think that vendor lock-in is a real thing. I think it's a low risk for those 3 particular vendors. And I think the cost of mitigating it by using 2 out of those 3 vendors is really, really high. That doesn't mean it's not a good idea depending on your environment, but you should really think through the cost associated with doing that. On the other hand, where I do think vendor lock-in, pseudo vendor lock-in is an issue that's not discussed frequently, is in the software dependencies that you bring into your application. For example, if you're building a Node application, and you npm install a package, you now have a dependency on the maintenance, support, and security patches for that particular dependency. And so it's really important to vet out the packages that you install. If you've run npm install recently, and I'm not picking on Node here because the same is true for most of your popular languages, but if you've run npm install recently, you'll see that there's like a whole npm fund section right now where it says, oh, this project needs funded, or this developer is looking for a job. And to me, those are early warning signs for dependencies that are either struggling to stay up to date or may soon, fall out of date because of lack of support. So I think that's where vendor lock-in issues really exist. Got about a minute left, so the next question, nothing in the chat that I see. So next question, using Nginx as a reverse proxy. So Nginx as a reverse proxy, what that means is basically it's doing the same thing that I showed you here with the Elastic Load Balancer. You know, it serves the same function as the Elastic Load Balancer there, only instead of using an Elastic Load Balancer, we would just have a little Nginx server running right here performing the same functions. So you can certainly do that. It works functionally the same. The thing that you have to be careful of when you do that, though, is that Nginx server is going to go down. At some point, it will be not available, maybe through no action of your own, but AWS loses different components all the time, and that takes down some of your services. So if you're doing that, you've got a single point of failure for your application. So if your reverse proxy goes down, then you just lost access to your website. The other thing that's worth noting about that is we talked about the Elastic Load Balancer's ability to scale automatically to help minimize the impact of DDoS attacks with a single Nginx reverse proxy. Same thing, it's not going to be able to scale unless you build auto scaling into it yourself, so that you're still subject to a DDoS attack and you would have to deal with that through manual intervention on your own. And that runs us out of time for our questions, which brings us to the end of our live stream and sets us up for the next one. So in the next one, we're actually going to start building our VPC, and we're going to set up the IAM roles and users that are needed for that. So if you don't know what IAM roles and users are, come join me next week because you'll learn exactly what that is. And if we have time, we'll add our VPN server into that as well. So I'm going to keep doing these as long as y'all are finding them valuable and interesting. We got to measure that though, right? Measure things is what we do. So we're going to measure it by the number of views that each one gets. So if this was useful for you, if you got something valuable out of it, please let your friends know, tell them about it so that they join in, and we can turn this into something that everyone gets value from. The last thing I'm going to ask you to do is, if you want to head over to DevOpsForTheRestOfUs.com, then sign up there. You'll instantly get access to a guide that I created, the 5 Steps to Incident Management. And I'm going to transcribe this episode. I'll put in links to everything that I talked about. I'll recap the questions that we handled in the Q&A session, and I'll email that out to everyone who's signed up on the email list at DevOpsForTheRestOfUs.com. So that's it. I had a blast doing this. I hope it was informative for all of y'all, and I'll see you next week. So long.